Alright, welcome back. I guess suppose this is the third in a kind of improvised series of tutorials about first getting a rig to work, animating the rig, and then this part will be about exporting the rig as a series of image files and then importing them into a game engine to use as an animated character. So here we have a witch. What we're going to do is we're going to export the animation. We're going to export the whole thing from frame 1 to frame 72. And these files can get kind of big if you have them in high resolution. They can get to up to 3 megabytes depending on how large the image is. So we're going to go from 1 to 72, which is 3 seconds long. We're going to save it to the desktop just for convenience. Yeah, I'm phasing out. Okay, and now you'll notice here that we have the compression type as PNG, not as MPEG, I guess, which is, oh yeah, no, this is what it is by default. When you export to a QuickTime file, Anime Studio will have this as MPEG 4 video by default, but for our purposes we need to export it as a bunch of PNG files. And also, if you are a Windows user such as myself, you will need to make sure that you have QuickTime installed from Apple's website previously. Otherwise you will not have the option to compress into a QuickTime file. I don't know about Mac users, but I would assume it comes packaged with Mountain Lion. But anyways, so now we have compression type as PNG, frames per second. Depending on what you want to do, you may want to put them as 30, but I find that leaving them at 24 is okay. Depth as millions of colors, that way you have the highest resolution possible. It also makes the sprites, or the images, as memory consuming as possible. And now we're going to click OK. Right now you see this being rendered, but that'll go away because I have it set to not render. I hope. Yeah, okay. That's fine. Also, what you get in the renderer is not necessarily what it looks like, but okay. Well, there's our witch. And now we need to collapse this. I have it somewhere on here. There we go. Okay, so now we'll make a folder called and actually, what is the file location? Alright. Now we're going to be using a script here that I found on the internet a while back. I don't remember where I got it from. I should. I want to give credit to the guy, but it's called Move to PNG, and it takes all of the picture files within this .move file and extracts them as PNG files, which they've been compressed as, and puts them into this folder. And it's kind of hard to use. If you have a copy of Photoshop, I think you can do this automatically from within Photoshop. But what you have to do is it's a Python script, and you have to put in the file path of the folder you want, and make sure you have the .move extension attached, and it will read, and you'll get all these files. Don't worry, don't freak out, because they are easy to get rid of enough, kind of. But this is why I don't like saving things to the desktop. But did I just copy all of those? Oh Jesus, okay. Yes. Oops. Alright, stick them in here. That is the one problem with the script. You can't choose where you export files to. But for the most part, it's pretty convenient. It's a little tedious, but anyway, for freeware I found on the internet, it's not bad. And so we should have two. I think we're. Oh, yeah, there it is. Okay, it's all kind of out of order, but make there we go. And we have 72 frames. These are all the files. In total, oh, this one's actually pretty small. This one isn't super big. I had a few really big ones. But like if you look at properties of the folder, you'll see it's pretty big. It's like 2 megabytes. But it won't be that large once you put it in game because you'll remove the background and scale it down. So now we're going to pop over to a program called GameMaker Studio. I use the professional version, so it has the HTML5 export as an option. But we will make a new project, name it whatever you want. I'm calling mine, actually not even animation test, animation tutorial, why not? Alright, and now once we've done that, here we have sprites. We can either go to create sprite or click this right here. We will call this one sprite which walk start. It's a long name, but it's useful for seeing what things do. And now where is there's the folder. Okay, so now we want to find, I think, was it the first 1, 2, 3, 4, 5, 6. So frames 1 through 6 we need before the first keyframe, and that is, oh, if you want to select multiple files within Internet Explorer, you can either hold Shift and click or hold Control and click. Now what we have to do is we need to erase the background color. Usually a tolerance of about 72 works. If you make the tolerance too high, the whole image will disappear. But yeah, 82 is okay, as long as nothing disappeared. Nothing disappeared. Alright, now we're going to crop the image. And now when I made this, it was supposed to be 64 by 64 pixels high, so that would fit into a square. I mean, not 64 pixels within Anime Studio, but I made it constrained to a square so that I would be able to resize the canvas to a square. And that should give you, that's not right, I did not do that right, okay. Raise this canvas to the bottom. Really? Oh yeah, because feet don't touch the floor. Alright, and then we need to stretch this down to 64 pixels by 64 pixels. The quality can be anything you want. Excellent sometimes has strange artifacts. Like here, it's kind of hard to see everything in the resolution, so I mean, normal won't make much of a difference. Sorry. That's the other problem with scaling down a lot, and you lose a lot of the detail. Like, it's kind of hard to see what this is. But this works. That's why you kind of want to exaggerate features when you're making characters, because it's difficult to see everything at these small resolutions that you need to make something that works. And so we're going to just make all of these now. We're not going to include the end animation because it's not super important, I guess. But 6 to 24 and 6 to 24. Alright. And same principles apply. Erase the color. Crop. And you know what? You actually don't have to resize the canvas. I did that kind of unnecessarily. As long as you have the height consistent, as long as you make this thing 64 pixels tall, you should be fine. That's not great. Is this? Actually, you shouldn't go by pixels. That's a mistake, because you should go by percentages. Is that the same? It looks, yeah, okay, pretty close. But with the other ones, crap. I should have kept track of what that was. There's two things when you're stretching images. There's the percentage you can stretch it by and the fixed number of pixels you can stretch it by. Usually you want to keep the percentage consistent, that way you won't get the character getting larger or smaller as you scale up and down. But 30 to 72, this is a really big one. This is actually the majority of the file, even though nothing happens. The still animation. 32, 32, 30, no, 30, alright. Alright. Oh, this is the monotonous part, just importing everything. Let me crop. Now this one should be 64 pixels tall no matter what. And I'm slightly concerned because I've seen different sizes for each sprite, which is slightly disconcerting. But the other thing is you also want to find a common origin. So here, for instance, I might go right there by roughly the center of mass, maybe actually a little higher. So like right there, or where it would look good if I mirrored the image. So 39 by 48. Just where does 39 come out? Yeah, okay, that works well enough. As long as the vertical is similar, it shouldn't seriously impact the rest of the sprite. Okay, so it looks like the origin is in roughly the same place, which means we've gotten this mostly correct. Now the last step before we can start programming this thing is we need to make a mask, because all the images have slightly different bounding boxes. And so what we can do is do something like this. Yeah, that should work. Although no, ooh, yeah. Okay, like that. So then, because I'm terrible at math, I just pull out a calculator and then do what are the numbers? You guys should see the numbers. So I subtract, to find the width, I subtract the right from the left, or whichever is greater. So I do 51 minus 22, 29, and then 62 minus 9. So 29 and 53. Those are our numbers. I should not have closed that calculator. And go to a new sprite, edit sprite, 29 by 53. Should be the dimensions for this new sprite. And just fill it black. Now the next step is to kind of preserve the origin, which is a little more complicated, but it looks like this is always a little complicated. Finding out where the origin translates to, you need to go here about, so it's about 26, and then to there is, I don't know how much of 29 that is, but it's probably, oh yeah, so I'm sorry, when I think aloud I sound stupid. So 39 minus 26 is where the origin should be, and 39 minus 26, math don't fail me now, is about 13. That looks about right. Since it's the same height, it's not the same height actually. That's not good. I should know where the heights are. I think where was it we made? I think that was about where it was. The origin for the mask, it should be as exact as possible, but the mask is also invisible. So as long as it's close enough as a bounding box, it should be okay. So 10, so 48 minus 10 is 38, and yeah, that looks about right. That's pretty close. It's good enough for me. So sprite which mask. And then another thing you may want to do is just create, if you want to have physical interaction, you could do sprite block. That way. Oh, load sprite. Sorry. And this one should be 64 by 64. That's like the base unit. Okay. Nice big graphics. Leave that origin to 0. Okay, so now you have the witch and a basic wall object. Now we're going to go to object, and we're going to make something called object witch. And we're use sprite which still as the basic thing, and I don't know. I'm not going to show you how to program character controls, but we can make this really basic enemy, I guess. So we can to take advantage of all of these animations we have here. We'll make a witch that walks around, stands still randomly, and then starts walking again. And just for fun, we'll build to HTML5 so I can show you what it looks like in the browser. So in the create event, we need to define all of the variables for this witch. And so if we want to have it move left and right, we might want to do something like x vector equals 4. So the witch will move at a rate of 4 pixels to either the right or left every second. I don't know. How complicated should this be? I don't know how complicated this should be. But we can also, we're going to use something called a finite state machine. I'm not sure I have it right, but for right now, I'm going to make the state 0. Now if we go up to define constants, we can make things like state still. So for every animation, okay, I have to explain what constants are. I don't completely understand these topics, but the way I think of it is user-defined constants are like variables. They're pieces of information written to memory, but you cannot change them once you begin the program. So it's like a variable written in stone. It's not malleable. You can't change the value once the program starts. And so they're really good for if you have a very complex number like pi, but you don't want to type 3.14159265535 into your code every time you have to use it in an equation. What you can do is you can make a constant called pi and type in 8.141592653589793233846. Don't ask me why. I know 20 digits of pi. But anyway, you can... Now that becomes a constant. So if I want to, in the code, I can do something like pi. Oh, wait. Oh, GameMaker has been smart and has already made that a constant, as most good programs have. But if I make it capitalized, there we go. So we can do, I don't know, 2 times pi. So show message 2 times pi. And when we run this program, we will get, let's go, 6.2831. Yeah, 6.28, that's 2 times pi. So we, instead of having to type in 2 times 3.14, we just typed in the constant pi, and the program, or the runner, or whatever you call it, translated that into the number we had put in. And so anyway, it's a constants are a really good way of storing just variables you want. So when we're using a finite state machine, we're going to have different things the witch is doing. So the witch will be able to stand still, the witch will be able to walk, and the witch will be able to begin walking. So that makes 3 states. So state still will be assigned the value of 0. State walk start will be assigned the value of 1. And state walk will be assigned the value of 2. And I'm just using numbers because you can't really compare strings in GameMaker. So ooh. Brain block, or whatever you call it. Okay, I'm out of it. I'm always out of it. It's annoying. Alright, so anyway, now we have these states, and instead of having to type in 0, 1, and 2, and remembering that 0 corresponds to still, 1 corresponds to walking, and 2 corresponds to also walking, we can just call these within our script. And it's also a good practice to keep your constants in all caps so that you can tell they're constants and not variables that you can change. So we will, instead of setting the state to 0, we will set the player's state to state still. And if we ran a show message of state still, that would return it would return 0. Okay, with the value that we defined. So now, because state is still, I don't know, well, we can set a timer or an alarm, as they call it in GameMaker, so that after 3 seconds or 90 frames, this is 30 frames per second times 3 is 90 frames, so after 90 steps, so 3 seconds, we will go into state walk, or rather state walk start. And so at alarm 0, we will go to add code. We will set the state to state walk start, and alarm 0 will become, no, not alarm 0, sorry. We will set the sprite index to sprite which walk start. And then we need to go to add event. We go to other, under animation end. So at the end of an animation, when this sprite finishes, every time it gets to sprite 5, it will return that the animation is ended. So what we do is we check for whether or not the sprite index, the sprite, oh, by the way, for those of you guys who don't know, a sprite is just an image, but in fancy computer terms, it's a little more technical than that, but at the bare bones, that's what it is. So if the sprite index, or the sprite that the object has, is equal to double equal sign sprite which walk start. So we need to make sure that we're at the end of the walk sprite. We need to set state to state walk. And that way we're in full on walking. We're no longer starting to walk, but we are walking. And at the same time, we will set the sprite index to the corresponding sprite for the state, which is sprite which walk. And if you don't follow me, I'm sorry. I haven't done very many of these, so I'm still kind of new to the whole tutorial thing. But anyway, yeah, and then also what we said we wanted to do earlier in the video is we wanted to have the which start walking, stop walking, and then start walking again. So we will set another alarm, alarm 1. Which are basically timers. They just count down from the value you type in. So we can set this value to, I don't know, 5 seconds. So 5 times the room speed. I say room speed instead of 30 just in case I either change the frame rate in the room editor, or the runner or the browser slows down and the frame rate actually drops. That way the times stay consistent. And at alarm 1, which is a different alarm, we've set a different timer, we will do something similar. We will set the state to I'm sorry, okay, state still, which will stop walking. We've left out the walk end animation just because in my experience it's not super important to have it. It looks a little jerky in the room, but it's not so bad. So the state equals state still. The sprite index we will set to sprite which still when it's at rest, resting, and we will set alarm 0 to, we can do 3 times room speed. And we can also say we want to mix things up a little bit. one thing we have not done is made the witch actually move. So we have all the animations in place, but what we have to do now is if we need to make a state check in the step event, which is the step event is an event that is called every step, every frame, so every time the game updates, which is 30 times a second, this event will be called. So what we do is we say if state is equal to, is rather not equal to, state still. So if you're anything other than still, then you're moving. We will add the previously defined variable x vector to your current x coordinate, and here's a twist. We're going to multiply that by the x scale of the sprite, and I'll explain why in a moment. Alright, so in the create event we will set also, I haven't left any comments here, which is bad, but we will say image x scale equals choose 1, -1. So we're mixing things up a little bit. That way we it'll randomize whether or not the witch is facing right or left. So the x scale of the image is how much you squash the image in any one direction on the x-axis. Let me better explain using the room editor. So if I come here and I click on the witch, you'll see this bounding box shows up, and if I stretch this, that is the x scale being stretched. But you'll notice that if I pass a certain threshold, like if right now, that's at -1, it's flipped itself. If I set it back to 1, it is flipped itself again. So it's a little bit like in Paper Mario when things flip back and forth. I guess if you have ever played that game, you can think of it that way. But so when I set the image x scale at a -1, the witch will flip. And actually, because our witch started out facing left, the x vector should be negative. Hi, Felix. My cat just walked in. Sorry. So yes, when we have the x scale set to -1, the witch will be facing right, and when we have it set to 1, it'll be facing left. If we were conventional, we would mirror all of these sprites so that the witch would be facing that way, and then it would be less technical. But now I'm rambling and being confusing, so instead of just talking, I am going to show you, and hopefully this will run without bugs. So let's see. Let's go. Save progress, and then let's build. Oh, where'd it go? That's not supposed to happen. Alright, sorry about that. You know what? Yeah, let's build to Windows. Might be slightly faster. Okay, so now we're in resting. Now starts walking. Alright, that looks good. We should probably shorten the length of time during which it walks. Let's rest for 1 second. Just so things are faster and I can explain more. That may have been a mistake. Make it maybe 3, but no more. Alright, and then at alarm 1, we can flip the direction of the sprite so that it doesn't walk off the screen. And we do this by just multiplying by a negative number, so that by -1, that way if it's positive it becomes negative, if it's negative it becomes positive. Basic math. And so now we say build. Okay, now hopefully this works. So there we go, walking, come back, no, oh there, stop, going back again, okay. And this is also a very basic form of AI. Now switch directions. It's coming back. Alright. And it'll do that over and over again. So yeah, and that is how we have gone from, in the first tutorial we had a rig, to animating the rig, to exporting the rig, to turning it into something you can see on screen or in a web browser. So that's kind of cool, and actually it's very cool because it lets you make really good looking graphics for your games. So it's a sort of graphics pipeline, really, and if you know how to work well with it, it's great. The script that I used to extract the move files, it may actually just be in Google. By Lebostein at gmx.de. Alright. So yeah, this is by a German guy. It just unzips. I've edited the file slightly so that it has it takes raw input for the thing. But if you want to find the thing, this script online, let me see. Google says it'll harm your computer, but I don't think it will. But anyway, that's the script I use. I use GameMaker Studio as a program for programming, and then Anime Studio Pro 8. So thank you for watching. Please rate, comment, and subscribe.